So today we're talking about how to architect public cloud instances for 99.99% availability. It's a complicated subject because it's not as easy and as simple as a lift and shift, because otherwise your sort of SLAs will suffer. So, and the reason for that is obviously AWS and Azure will go down, and you need to sort of not think of it the same way that you would for your on-premise infrastructure. So we take a traditional IT environment where we might have, say, for example, 2 hypervisors. We've got a SAN that underpins all of that, and we probably getting on site at the moment something like 99.99% availability. Now, when it comes to public cloud, you need to optimize to try and achieve the same SLA, because believe it or not, the SLA varies massively in terms of what you actually get in the environment. So the first 2 things that we need to talk about are what are a region and what's an availability zone. So if you think about a region being something like, for example, I'm not going to draw the UK map because it won't look very good, but if we said this was London, that would be our region. So depending on which public cloud you're using, some call it UK South, some call it EU West. So that is our region. That's effectively an isolated environment where you can deploy instances to. Well, should I say you can deploy into availability zones. So London is the region, and then inside that region are effectively availability zones, which are effectively data centers. So these are different data centers where you can deploy your workload to. So they could be a few miles apart, they could be next to each other. It really depends on the region itself. So that's the simple thing. Think about the region is the geography and the availability zone is the data center. So for AWS as it stands today, London is actually called EU West 2, and that's actually split into 3 availability zones. So 1, 2, 3. Now these have a different name, so they have a different naming convention. However, for customers, just because availability zone 3 is 3 for you, it might be 1 for somebody else. So they'll actually mix that up between clients to keep workloads spread around, because everyone might stick it on availability zone 1, for example. So why this matters is that we tend to think about single servers or virtualized workloads across a number of hosts that offer a certain level of availability, as we've sort of spoke about, sort of this 99.99 being quite typical. And to give you some idea, this is equivalent to probably about 52 minutes a year of downtime. So in public cloud, we need to think a little bit differently, because a single EC2 instance within a single availability zone actually has an SLA of 99.5%, which is actually 1 day and 19 hours of potential downtime over the course of a year. So you can't just think about lifting a single VM out of this farm and transition it straight into AWS, because if you do that, things can end up in a bit of a mess and you're going to reduce your availability. So what we need to do is architect things a little bit differently. This means to basically set them up for public cloud to make sure that we get the same availability that we've got here inside our public cloud environment. And that means having infrastructure across multiple availability zones within a single region. You can do multi-region, but adds a lot of complexity, and for the purpose of this video, we'll just show you what that would look like across. This means having resources split across multiple availability zones with EC2 instances, because we want to get this, the target SLA is 99.99%. So if we were to look at, for example, a design, so fairly atypical in an on-prem environment, we might have like, we'll say 1 IIS server and 1 SQL server, which could be running our application that we've got. This might be running like a database for a HR system, and this is running the web front end for it. So we want to move them into public cloud and maintain that 99.99% availability, because we don't want to take a step backwards, because this particular application is mission critical. Perhaps it's feeding other systems that need the data. So in terms of the structure, what we do is we look at using the EU West environment. And what we'll actually do is look to build across 2 availability zones. So the first thing that we'll tackle is IIS. Now, you could probably use something like Elastic Beanstalk, but for the purpose of this, we'll assume that we're just going to choose an EC2 instance. And what we'll do is we'll build one EC2 instance inside here on one availability zone and one EC2 instance here across another, and deploy the application itself, the actual web server components, across these 2. Now, the next thing we need is a load balancer that's basically going to redirect that traffic based on either across both of them or whichever one is available. And then the next component we need, so that kind of ticks off the IIS piece. The next bit we need is the SQL. So what we use for this is Amazon RDS deployed in a multi-AZ configuration, and that basically will sit here as a separate layer. And what we'll do is we'll novate the database into RDS. So that basically ticks that off. So what we've now got is an application deployed that delivers the same availability as our previous environment. And yeah, that gets us past the sort of 99.5% risk that you have if you design within a single availability zone, and gives us a really nice clean environment. So it's quite easy to see how easy this is to overlook when you're deploying public cloud, and how easy it is to effectively end up with a worse availability than your on-premise environment. So yeah, we hope that this video was straightforward enough and that it's been informative for today. And please, yeah, check out the rest of our videos, like, comment, and subscribe.